One of the questions that I normally do here is, what can you do with used EV batteries? At what point do you think those batteries need to be sent to a recycling facility?
But generally, there's like a standard for what's classified an end-of-life battery, and it's based off of like the state of charge of that battery. Generally, when it's new, has 100% state of charge, reaching around like that 70-80%. What I've seen is now classified as end-of-life. Maybe for the end-of-life, in terms, you can always ask that question, like what terms, right? Is it end-of-life for the electric vehicle, right? And then others will say, well, there's still charge in it. Maybe that can be used in secondary storage. So there are applications, or maybe that battery is in a bad shape or part of an accident that just goes directly into recycling, right? So there's different approaches to that, but generally it's going off that state of charge, or how many cycles that battery has gone through, charge and discharge cycles.
With the number of electric vehicles that are there in the market right now, and how many vehicles are actually there to recycle the lithium from the batteries?
Yeah, I mean that's a common misconception, right? Everybody always thinks about like what they can directly see in their electric vehicle, and they ask what happens with this with the battery afterwards, right? And a lot of times electric vehicles are new and there's just not enough volume. But what many don't understand is that when the batteries are being made and all the new, the term gigafactory, like where the battery cells are actually made, there's a lot of waste being produced there. And that's really where the recyclable material is coming from. So that's essentially taking, like I mentioned earlier to you, there's a really fine, like very specific quality that the battery needs to be. And there's a lot of testing that's involved with that at the gigafactory, and when you're making it, from the purity of the materials to how it's formed. And this is really to avoid some of the recalls that we've seen in the world, right? From exploding phones or recalled EV battery packs. So it's really important to get that quality down. And most of the time it's not. And those numbers can be 10, 20, 30%, even more of the battery production capacity at that plant. And that's just going directly into waste. That's not even going into a cell yet, or that's not even going into an electric vehicle yet. So that is really where it's a key opportunity to recycle, and then you can recycle directly at the gigafactory. So really with our technology, we want to enable these companies, these gigafactories, to recycle their waste and more so approach, not talking about making 20 or 30% waste, but zero waste manufacturing. Because if you could cycle that material back on the same environment, on the same footprint of the gigafactory, that simplifies things and really improves efficiencies.
So would recycling lithium and the other metals reduce the cost of making new batteries, or would it be similar costs, or do you think the cost of recycling might get added to the cost of the battery?
Yeah, when I look at like just the conventional supply chain right now, in terms of mining cobalt in Congo, mining manganese in South Africa, lithium in Australia, nickel in Indonesia, and then all of that gets sent to China or Asia Pacific region to be refined into materials, and then those materials are shipped to North America. Like I don't have an exact dollar number for you, but when you just look at those steps and the transportation and the processing involved versus taking material that's already classified as like off spec, like I mentioned earlier, and scrap, and reintroducing that directly on site, I think there's a much higher efficiency that can definitely reduce costs of a battery. Where legislation goes in terms of who's responsible for that cost, I think as we see like in Europe and Asia, there's a lot more focus on EPR, which is extended producer responsibility. So where the producer is more responsible for taking that back. So I don't know if that's going to be in the future where they add on that cost at the beginning, and then once the battery is at the end of life, they collect it back. But that's all still evolving right now, and it's still not very clear. Actually, maybe I'll add as well, a lot of the, like, if you look at the warranty of a lot of these electric vehicles right now on the batteries, it's 8+ years. That's where the timeline of the electric vehicles that are out there is not there yet. So a lot of these are still under warranty. So it is the producers. The producer does have to take it back right now, anyways, and handle the claim, right?
So what do you see as an ideal scenario for the EV industry, like what we'd call a circular economy, or how would you describe the ideal EV industry?
Well, from our standpoint as like RecycLiCo, we're really focusing on building the technology to enable this. But unlike mining for these resources, for battery waste, you're not really sitting on that resource. You're not in control of that resource, right? So who is going to be the electric vehicle manufacturers, and the battery manufacturers are producing the waste. And at the end of the day, I think an ideal scenario is where they're going to integrate their waste material into future battery production and extracting those materials. And our standpoint as a company is to enable them to do that with our technology, and that's what we're focusing on. So it's not to be a standalone recycling facility that takes this waste and then it goes through the complex supply chain and eventually ends up in the battery, but more so to do it directly, on co-located on one site. So that's the ideal scenario. I think that'll start with battery manufacturing, taking the waste material. So like you see here, these are trimming materials that would come from battery production, and this is essentially aluminum with a coating of lithium, nickel, manganese, and cobalt that's on here, and directly, with our process, being able to produce different lithium products like lithium carbonate here, lithium hydroxide, and as well as the high value precursor products, right, that then are battery ready materials to be reintroduced into future cell production. And that's all happening on like one battery complex, and that's really how I see it. And then I'll just add as well, that's from a battery manufacturing standpoint, but for the customers, I really see there's already a network of dealerships. You go in to, if you have a problem with your car, you take it into a dealership to, or the shop that they have, and they'll evaluate and see what the best steps are, and that's a perfect collection point in my eyes in terms of collecting the batteries and then sending them all to like one central location to be reprocessed.
So what do you think is the environmental impact of this whole recycling process that you have, like in terms of air pollution or water pollution or everything put together? What do you think is the environmental impact of recycling?
Yeah, well, I mean, you don't have to really hear it from me. We've actually had third party analyze and do an assessment of our process and compare it to others. So it's not, I'm not telling you any kind of calculation we made up here, but this is done by a group that does consulting for, it's called a life cycle assessment, and they look at that global warming potential. They compared it to mined materials, so from mining material to making the product, and as well as some of these competing processes that also claim to recycle materials. And what we've shown is significant reduction in CO2 emissions and in many other different impact categories, but from water use and CO2 emissions, right? This will also play a factor in terms of where the plant is located, but definitely what we're seeing, the number when we compare it to, it was like 166% variance in terms of a competing recycling process versus our recycling process, and that's really due to our use of minimal amount of steps, really practical a practical approach in how the material is made, and to our patents as well, right? This is one of a kind of process that's being done, and this was evaluated. I mean, we have when you when this company is evaluating our processes over 1,500 different streams of inputs and outputs, and tracking every little bit of CO2 or water use that's used, and to get to these numbers. So yeah, I mean, that's those results are as well, like on our website and available there. But there are ways to significantly reduce it, and it's, I guess there is a reduction from mining the material, obviously, right? There was a reduction, but I think what we also wanted to show is that not all recycling processes are green. Just recycling was constantly titled as green, but what we've shown is the drastic reduction in one recycling process compared to ours, right? So there is a big disconnect there as well, right? So I think we shouldn't just be classifying recycling as good. You really, I think, have to dig deeper